My name's Jonathan. I need to make an internally threaded collar that will screw onto the quill of this pillar drill or drill press and hold the scale for positioning, measurement, and also a guard that will go up and down with the drill. To make an internally threaded collar, I need the pitch, the threads per inch, the outside diameter and the diameter across wires using thread wires, and the angle of the thread, and that's it. And with that information I can make a duplicate of this piece of thread and use that in the lathe to test when my threaded collar is the right size and take it out the lathe and bring it and fit it. I can calculate the minor diameter, which is effectively the diameter at which to stop boring out the collar and start threading the collar. We'll get onto that. This guard slides and it works, it's great as far as it goes. Doesn't work. Does work. Can't open the gate. Can't open the gate. But it doesn't go up and down with the drill. So I want one that's going to go up and down, a guard mounted on that thread. It'll go up and down with the drill. That's the plan. Using the 3-wire method, one wire goes on one side here, the two others go on the other side, and then a micrometer will take the diameter on the wires. You might notice in some of the video there's some interference patterns appearing on this thread. You get some very funny effects. It's due to the fine pitch of the thread, to do with scan lines in the video that interfere with the lines in the thread. I think that's about it. 2.9595 plus half a thou and minus half a thou. So I'm going to go with 2.958. Looks very neat, but is it 24 TPI? Looks like it. Bit raggedy. The thread was quite hard to see. I think it was a combination of the material, aluminium, and perhaps the edge on my high-speed steel cutting tool, and the quite fine pitch I was cutting. For this reason I decided to go for a better tool, or a different tool, when cutting the actual internal diameter. I increased the speed of the aluminium work at this point to try and get a better cut from the high-speed steel tool. That's a bit better. Outside diameter of the thread first. Seems to be about it. 2.950. I thought I was down to 2.933, which is this diameter. So it's raised burrs basically. Yeah, 2.934. Must be raising burrs. Let's see what the grooves are like. Right, let's try 2 wires there. And 1 wire. On the wires. Right, that seems to be about it. I can't read it from here. I can see 1 wire. And the measurement is 979. I tried using various shaped needle files at this point. The flat ones to reduce the height of the burr and the triangular ones to try and clean up the edges of the burr. 2.93433. So I've made it spot on. I'm going to have to get my hands greasy. So whilst the major or outer diameter is the same as that on the drill after working with the files, I've ended up with the test plug diameter across the 3 wires being 10 thou smaller than it is on the actual drill. So having produced a test plug for the internal threaded diameter, now start on the collar itself. It seemed easier to start the bore in the drill, as the drill has an auto feed and will take a Morse taper 3 drill, whilst the lathe only has a Morse taper 2 and that's got a manual feed on it. And then transfer it to the lathe and use the boring bar. I could have used a Morse taper 3 to Morse taper 4 converter and gone for an even larger drill, but it never crossed my mind at the time. This is the thread I want to cut, or the matching thread. I started off with a small 6mm boring bar, but once the hole got a bit bigger, was able to get a larger 10mm high-speed steel tool in there. We're getting a bit closer to the diameter. The target diameter here is the minor diameter, calculated using the major diameter minus 1 over the pitch, taken from the actual drill. .597 inches. .891 is my target. Shame I didn't leave any minor diameter protruding here to use as part of the test. We won't go in now, but hopefully it will when we've done some threading. I'm using a carbide tip tool here to try and get a better finish on the internal thread than I did on the external test plug thread with the high-speed steel. I've also increased the RPM of the work and changed the gearing of the work to the drive, to the cutting tool, so that I'm not in back gear anymore. I don't think that helped at all. To 30. Back, out to 30. Back. One. Five. Into 5. Back. Out to 5. Hey, look at that. Coming up to 1. Into 0. Back. I've put some blue on the thread. I don't know if it'll help reveal anything about it going in or not going in, but it won't do any harm. It goes in about 2 turns at the moment. Well, I'll try one more cut. into 30, back, out to 30, I can just see the end of the plug now approaching down the back. I'm going to put a centre drill and a hole in the middle of it so I can put a bolt in and perhaps glue it in or pin it in or something that would save all this if I have to go back and forth by hand. It'd be a lot quicker if I could just put a socket in the drill and whiz it in and out if it needs cleaning up, and it may well do. The question is this block going to screw onto the drill? I'm going to take it out and try it. I've only got one chance at this. With such a fine thread and it being an internal thread, realistically there's no chance of lining up the tool with the thread if it were to need some more work. But having said that, we've done all the right things. I've got to say it's quite a good fit, although there are some tight spots here and there. Well, it's quite tight. Well, no, it's not tight. Sit something there. There's one or two little blemishes on the thread. I don't know if you can see them. If I zoom in, there's a couple here, just where my fingernail is. Let's see if this will move them. 24. I've taken off one or two blemishes with this thread chaser, 24 TPI version. As you can see here, I've made a temporary handle that I could bolt onto the block to give me some leverage. So having required a bit of leverage to get the collar to fit all the way on the thread the first time, I then unscrewed it, cleaned up the threads on the drill using the thread chaser a bit more. As I suspected, they were the cause, or at least a contributory factor, to the high spots, the tight spots rather. And after doing this, the collar was relatively easy to screw on. Certainly didn't have to resort to a piece of pipe for extra leverage. So I'm quite happy with the result. Yeah. I hope I've shown that by using an intermediate step, I'm making a gauge to duplicate this piece of thread. That's a threaded collar can be made for a part without actually taking the part to the lathe to test it just based on measurements. As for the burrs that appeared on the Go test plug, I think that's down to a combination of the speed I was using, the material and the edge on the threading tool I was using. I could have taken more time sharpening and honing the single point threading tool and perhaps used a different material for the test plug so that it had a better finish without any burrs which affected the dimensions. I did use the cross slide to increase the cut on the thread, both doing the external thread and the internal thread. Whether using the compound slide at 29.5 degrees would have made a difference, I don't know, but it's a thought. I was wondering what difference it would have made if I'd got the dimensions of this right so that the measurement across the 3 wires wasn't 1/10 under that on the actual drill. And I think that would have, well, that would have produced a gauge 1/10 thou bigger across the threads, obviously. Internal thread would have had to be 1/10 thou bigger for the gauge to actually fit in, and so the tight spots that were encountered when trying to wind this on may not have been so bad. So in the end, I hope it's been interesting, and thanks very much for watching.